Hi everyone, welcome to this meetup. So for our, let's say, event for our first event for this new year, let's say it like this, we are pleased to welcome Mohammed Nofal. So you can introduce yourself in a few seconds, but he is here to talk about something really interesting, but I'm not expert in, but that could be really interesting for us. It's called Dapr, and you will see what it is. And I think it will be really interesting for us. So welcome, Mohammed, and floor is yours.
Thank you so much. Hello, everyone, and good evening. My name is Mohammed Nofal. I'm an architect in a team called the Global Black Belt team in Microsoft. We are a team of, we take care of like specialties of verticals, technology verticals, and my technology vertical is application innovation on Azure. I'm based out of Luxembourg, and I do cover EMEA, so Europe, Middle East, and Africa out of Luxembourg. So I really travel much across Europe and Middle East and Africa and help customers to modernize their applications and deploy them into the Azure Cloud. In the past few years, my primary focus was mostly on containers and Kubernetes, because this was probably the hottest trend, and still. I do speak in different conferences and different meetups and so on, but it just occurred to me a few months ago that I never spoke in anything that is in Luxembourg. So I reached out to you on, and we organized this because I want to be connected to the Luxembourgish community, learn from each other. Probably in future events we may meet in person. So that's it. That's me. 5 years in Microsoft, by the way. Before that, Amazon Web Services for 4 years, and before that, mostly in the telecommunication industry, building distributed systems. Today's topic is about Dapr, distributed application runtime. Right. So I take it that everybody in this group understands what microservices are, so I don't really have to explain this. But what we see as common challenges across all customers that we talk to when it comes to microservices is once you have like distributed microservices, which means like multiple teams working different services, each of these teams will use their own tooling, and these toolings are normally disjointed, right? So there is no common knowledge, and they cannot be, it's not reusable, whatever they're going to come up with, because each team is using maybe their own programming language, their own tooling, and so on, and hence there is not enough shared knowledge in there and reusable components. The other thing is, like, most of the runtimes that offer any abstraction for microservices are very language specific, and they're tightly coupled on what they can deliver and what they integrate with. And lastly, these runtimes are also coupled with infrastructure. They're very tightly coupled as well to infrastructure. And on the infrastructure end, in the past few years, there was the invention of containers and then Kubernetes. So containers deliver to us a single unit of deployment that runs on our local machines. Then it could be moved to VMs. It could be deployed to clusters or status of source and so on, and the cloud and so on. So it offered this single unit of deployment that can live anywhere for us, and it doesn't change. Then came Kubernetes in around 2015, which offered to us a way to manage multiple containers, right? So it did the orchestration part for us, and it offered enough infrastructure abstraction for us, for our application to be more or less consistent across different data centers. So Kubernetes offers things as unifies the way we ask for storage, for instance, unifies the way that we ask for network services like load balancers and IPs and so on. It unifies the way that we deploy our applications. But most of these things were tightly coupled to the infrastructure. So we have a lot of infrastructure abstractions, but there was not enough work that happened on the application end in order to abstract enough of the application and to ease and simplify the building of microservices. By the way, if you have questions, please list them in the chat. I'll just rely on you. If there are questions, then please just let me know, because I'm just focused on the screen. And this presentation will be split between slides and demo. Hopefully, I'll be able to go through the whole content that I have and the demos that I prepared. If not, then probably we're going to have a different venue for this, but let's hope that we're going to go through it all. Right. So this is technically where Dapr comes in. So Dapr, again, stands for Distributed Application Runtime. It was built to simplify the building blocks for microservices, to offer a consistent way of how we build microservices that really are distributed, built in different languages, and so on, right? Dapr is an open source project. It was born and incubated in Microsoft a few years ago. Then it was contributed, of course, to the community, and it's 100% community driven. So it's not really something that is just Microsoft specific. The idea of Dapr is to be application specific and vendor neutral in that sense, right? As such, Dapr is part of the CNCF, the Cloud Native Compute Foundation. So it's what's donated to the Cloud Native Compute Foundation. So we can introduce a governing body that is not, not vendor specific. So the Dapr is there in CNCF, and again, it's fully owned by the community. We still, of course, have some core internals at Microsoft. They do things not necessarily just Microsoft specific. They do things that are Dapr specific in that sense. Right. So why did we, or what are the principles that we used while building Dapr? First of all, we needed to make sure that whatever we build in terms of building blocks, they offer best practices out of the box. So for instance, common things in microservices, like how do we handle retries and backups and at least once delivery and so on, all of these should be handled by the components or the building blocks that we can offer in Dapr. We need to offer consistency in the way we code APIs across applications. We need this building blocks to be portable, so it runs in any data center, and we need to offer it on open APIs. So Dapr runs on both HTTP and gRPC, right? Of course, being open source, it means that it's extensible and pluggable components. So you can use one of the components, all of the components, it's as you choose. And then the very important thing is it supports any language and framework. It's not really tied to any language. It's not tied to any framework. You can always use the HTTP or gRPC API, assuming that you can from your application to use Dapr. If you don't fancy using HTTP or gRPC directly through Dapr, you can use the Dapr SDKs. So we have different SDKs for Dapr. .NET and Java and PHP and Python, so you can really go and build the code and or build the logic inside your app for Dapr. If not, you can just use the HTTP and gRPC APIs that are offered already out of the box from Dapr. It adopts standards, of course, being part of CNCF and an open source project. It adheres to certain standards that are community driven as well. And then again, it's platform agnostic. It runs anywhere. It runs on premises. It runs in the cloud. It runs on the edge. If it's a Raspberry Pi device, then it runs there. So on, it runs a Kubernetes cluster. And then again, it's community driven and vendor neutral. Right. So what are these building blocks? Right. So this is how like a normal application in Dapr would look like. So you have your application code. Which is again written in any language. There are SDKs for these languages, but again, you don't have to. So in order to invoke Dapr, you have HTTP API and gRPC API. So if you have a gRPC server, then you can just invoke Dapr as well. If not, then HTTP API works perfectly. And then these are the things that Dapr offers out of the box, right? Service-to-service invocation. We're going to go through all of these and what they do and so on. That's like service discovery, state management for building stateful application, publish and subscribe for pub-sub patterns, resource bindings for input and output. I need to react on a specific event coming from a specific service, or I need to emit a specific event to a specific service. The actors method, which the framework of the actors, if you know this, like if you know the Orleans project or ACA and so on, this is the actors method. And we're not going to go through this much in this session because this is very deep and it's its own session. So we're not going to talk much about actors. We're going to focus on everything else. By the way, actors is the only thing that is language specific in all of this, because actors is very language type or type to languages. So there are actors for .NET, Java, and I think Python as well out of the box. Observability. So we need to offer observability across microservices. That's distributed tracing and metrics. We need to offer a way to manage secrets, and of course, a way to manage configuration. And on the hosting end, it runs anywhere. So it runs in Microsoft Azure, right? And VMs or Kubernetes. It runs in Azure Arc. If you don't know what Azure Arc is, imagine getting the Azure resource provider or the control plane for Azure, and then extending it to your premises. So you can manage your VMs and your Kubernetes clusters on premises using the Azure API. So that's what Azure Arc does. And then it runs in Kubernetes, running anywhere. So we have customers running Azure, running Dapr in the AWS, Google on premises. It doesn't really matter because it's its own component. And on premises, assuming you have the cluster of VMs or Kubernetes clusters, it also runs there. Right. So a bit more on the building blocks. So these are like the building blocks. These are like let's say the services that Dapr offers, right? So the first one is service invocation. This is where we do service discovery, we do mutual TLS, we do retries, and timeouts, and so on. And state management, this is where we do state management, right? So you need to persist a state, right? You need to read, you need to query. Query is a new API in Dapr. That's for the more complex querying. So that's all done using the component that is state management. Pub and sub, publish and subscribe. That's also something that is offered. Binding and outputs and so on. So I'll go in each one of these and explain exactly what they are. Right. But just to emphasize more on the fact that Dapr isn't Microsoft specific, right? So these are the different components and the things that already are there for you to integrate with, right? And this is not exclusive. I'll share with you the links where you can look at the latest components, what are there already, and so on. So this is just an example of the components that are available. For instance, for the state store, there is Azure Cosmos DB, there is AWS DynamoDB, Firebase from Google, Redis, and Cassandra, PubSub, there's RabbitMQ, SQS, Service Bus from Azure, and so on. So as you can see, it's not really Azure specific or Microsoft specific. It's if you have a specific component that is common, you can most probably you're going to find it in Dapr. And then if you are interested in a specific scenario, Dapr is an open source project, so you can. So this is the GitHub link for the contribution for the components. You can just go there and contribute your own components. So again, it's community driven, so you can do all of this. Right. And the way that Dapr works is something called the sidecar model, right? It got publicized by using containers, of course, sidecars, which means that your application will be running, and then there will be a sidecar, either container or a process in case of Azure, so in case of Dapr. So it's not necessarily just a container. It could be a process as well, assuming that you don't use Docker or you don't use containers. And that sidecar will act as a reverse proxy. So it's going to intercept all the codes that are coming out of your application or into your application, and then it does the services that it's promised out of it, right? So for instance, the invoke API, so the service discovery one, all we need to do this is post localhost 3500. That's the default Dapr port. This is, you can change it to whatever you like. V1, that's the API version. Invoke, so I need to invoke. That's the application name, the card service. So I need my application to invoke the card service. The method is new order. So that's the new order. This is an API that is exposed using the card service. And as you can see, we didn't say anything to it, like where the invoke process is and of the services and so on. The invoke service, we just told Dapr that I need to talk with the invoke service. Dapr should go and find where the invoke service is, right? So that's an example for the invoke or the service discovery. That's an example for state. Again, the same construction for the URL, but then the component is different. That's the state. And then now I need to persist in the inventory component of the state, item 67, right? That's an application. That's another example for posting a topic to a broker called shipping, right? And then lastly, that's getting a secret from the key vault, right? So all of these are examples of how you can interact with Dapr in general. Let's talk about like where you can host Dapr. And then we're gonna go and provide more examples on the different components. We have two modes for hosting Dapr. In fact, there are three. There is a self-hosted one. So self-hosted is running Dapr on your local VM. So that's our local machine. So that's for development purposes. And there is a new model now where you can just run Dapr in a cluster of VMs. So you have any cluster of sorts. You can just install the Dapr control plane in that VM and that cluster, and then make use of Dapr as well. The only difference there is that you need console. That's HashiCorp console to do the service discovery pathway, right? But nevertheless, so assuming that you're self-hosting Dapr on your local machine, which we're gonna also demo today, Dapr init will just initialize Dapr. That means that installing the components for Dapr. And then to run your application, you need to do a Dapr run. So it runs the application and runs the sidecar for Dapr next to your application. If it's too complex, I know we're gonna explain all of this. We're gonna go through the demos as well. So, but just bear with me for a bit. In Kubernetes, we need to do the exact same thing, Dapr init, but just -k, which means that I need to initialize Dapr in Kubernetes, right? And then it deploys the Dapr control plane. And then the Dapr control plane will ensure that it injects the Dapr sidecars in the deployments that I annotate that need to use Dapr. So I need to annotate my deployment that, hey, I'm fine with using Dapr. And then Dapr control plane will go and inject itself or inject its sidecars inside these deployments, right? Right. Commercial break, if you need to use the managed Dapr environments, there is the AKS, so that's the managed Kubernetes offering from Microsoft, Azure Kubernetes Service. There is an extension for Dapr there. Now you get Dapr fully managed there. Or if you need to do fully serverless Kubernetes offering with Dapr, that's Azure Container Apps. It's fully serverless Kubernetes, and then you get Dapr there, so out of the box, so you don't really need to manage anything. Right. So how does it look like when you have Dapr in your local machine? Once you do Dapr init, the Dapr init will install these three components, right? A Redis state store, that's for state store, right? Again, you can install any state store, but that's out of the box is there. And then you can use like Cosmos DB, you can use DynamoDB, you can use MySQL, Postgres, whatever. That's your preferred state store eventually. We can install Zipkin for tracing. That's the Zipkin protocol and its implementation for Zipkin, the application. And then we have the actor placement. That's assuming that you're using actors. Right? Once you run your application using Dapr, we're going to create the mapping table for the actor instances, assuming there are actor instances. So just scratch this part because it's going to confuse you. We're going to start sending distributed tracing to the Zipkin, and then we're going to save and retrieve state for the Redis, right? If you do Dapr run my app, I'll show you an example of this. Then we're going to launch the application, launch the sidecar process, and then, of course, bootstrap the environment variables in order for Dapr or the application to be able to communicate with Dapr, right? And then once you have all of this, you can interact with any of the Dapr components in order to save state and PubSub and so on, right? And again, it runs on any of the, so it runs in Windows, Mac OS. I'm using a Mac machine in here, and then I'm running Dapr there. When it comes to Kubernetes, more or less it's exactly the same. So the operator will initialize Dapr there. We're going to get similar components without the state store. So we're going to get the actors. We're going to get the Dapr runtime injector. This is the pod or the deployment that's going to go there, and assuming my app had the annotation that Dapr is enabled, right? This one will intercept the traffic and say, inject the sidecar for Dapr to my application. So you can have like 100 applications and then only half of them are annotated, and then they're going to be using Dapr. So you don't really have to, it's not one or nothing. So you can partially use Dapr. And then we have something called Sentry. Sentry is the provides a certificate authority, the mutual TLS across your services, and provides identities. If you know Spiffy, then it uses Spiffy to provide identities for your microservices. And then we have the Dapr operator pod. That's an operator pod, so it manages the installation and the updates and so on for Dapr stuff. And again, it runs in any Kubernetes environment that you may choose. Once you do this, again, you have access to all components. Yeah. Okay, so now let's delve a bit more into the specifics on how they work. Service invocation. So service invocation, there are a few problems that we're trying to solve with service invocation. First one is service discovery. My app needs to find service A. How can I find it, right? Then I need to have secure communication between my microservices. How can I encrypt the traffic between my microservices? This is another thing. Then I need to ensure that I have some sort of timeouts, retries, backups between my applications or between my microservices. And then lastly, we need to standardize on the API requests between my applications, right? Because mostly what we see across customers is if you have multiple, like it's a large application and multiple microservices, then each team will create their own APIs their own way, and then you need to figure out like how each team just does their APIs and their coding, right? With Dapr, we're trying to unify on the API. So assuming that you need to do service invocation, so your app will technically call the Dapr invoke method, right? So what we're trying to achieve here is we need to call the method that is new order and service A. So that's what we're trying to do. So what we did is we posted a call to the Dapr URL, right? Invoke service A. That's the name of the service. The method is new order, right? So the call will go to the Dapr sidecar. Dapr sidecar will go and check where the service lives, right? So as you can see, there is no IP, there's no FPDN. We just provided an application ID for Dapr sidecar, and then it's going to go to the name resolution service. Assuming you're running on your local machine, Dapr will provide multicast DNS for you. If you're running in a cluster of VMs, then you're going to have console from HashiCorp. If you're running in Kubernetes, then that's the Kubernetes DNS service that is provided already, right? So we're going to go there, we're going to find the service, and we're going to, the Dapr sidecar will forward the code to the Dapr sidecar of service A, right? Now, it's worth mentioning that between my app and Dapr, I have two options. I either use HTTP or gRPC, right? Between the Dapr sidecars, we only default always to gRPC. That's because it's faster, right? So that code you don't really interact with. This is the code between the sidecars, and we always do it using gRPC. And then the sidecar on service A will receive it and then forward the call to service A. It does its business logic and then technically just return the code, right? So that's the service invocation and how it works in general in Dapr. Now for publish and subscribe, what we were trying to do, achieve there is we needed to provide an agnostic way of how you can interact with different message brokers. Right, so that's exactly what we're trying to achieve. And regardless of what the message broker is, we needed to standardize and we needed to offer also some sort of best practice, for instance, at least once message delivery, right? So my app, again, assuming that the message broker for me is Redis. Again, I keep mentioning Redis because it's simple, but like you have different, like you can use SQS, you can use Service Bus and so on, right? So my app will post a call. So that's, I need to send a topic, right? Publish a topic to a message broker. So it's a post. Again, instead of the invoke now, it's publish. I'm going to invoke on the orders topic, and then I'm going to create a message call process, right? Then on the other end, these are the subscribers, right? Dapr will also subscribe to the Redis cache on the topic, and then technically just get the messages, right? So that's what it's going to do. So in that sense, your application really doesn't really care about like what the message broker is. So you can replace it as cache by SQS, and then the logic exactly the same is the same in your application. Dapr is the one that is handling or having the whole logic for Redis or SQS or whatever, right? So your application for it, it's going to always use the same logic for calling. And then you can imagine that you can replace that state store or that public, like that message broker with any other message broker, and the logic remains the same. Now, how does that work and technically, right? The way that we create Dapr components is using YAML files, because yeah, the whole world is YAML now. That's the API version, that's the component. So we define this component. Now in the metadata, the name is orders, that's the name of my topic or the name of my message broker. The spec, this is type pops up with Redis, right? So now my type or my message broker is Redis. You can replace this with SQS and so on, right? And then the metadata, the other metadata for that message broker is like, where is the Redis host? And then this is a secret reference for how can I interact with the Redis cluster, right? Again, the application to sidecar, this is a post message that's you publish it, and then on the sidecar ends, the subscribers, this is a get message for the subscriptions, right? On the state store, again, most of the applications that have some sort of state that it needs to persist. So Dapr also have an abstraction for this, which is the state management. You can post, which is write a state to a key value store, or now we have integrations also with MySQL and Postgres, so you can also in a relation database as well store state there. So again, the same URL for the invocation, instead it's state, and then we persist the state and a Redis cache, right? If to get the state is exactly the same, but it's the same code, but it's just now get with the key, right? Now you can imagine that we can replace the Redis to Cosmos DB, for instance, and then have exactly the same logic in the background. The application code didn't change; it's just the component or the store for the component just changed. Again, it's more or less exactly the same as the pub sub. The name of my component is corpdb. That's Redis, and then this is how I'm finding my Redis, and then this is how I save state, post state, and then retrieve state, and then delete state, and so on. Well, there is a new API that just got introduced. I think I covered in the beginning. It's called the query API or the query component. That's for the more sophisticated queries. It's still new, but you can imagine that you can use these type of APIs for these type of things, so save and retrieve and so on, and you can use normal queries for the more sophisticated things. And then again, like if you want to change from, assuming that you kept the same logic, you could change keep the same name for your state store and then the state Cosmos DB, and then you should expect exactly the same behavior from your application. Right, observability. We need to have observability across our application. We need to be able to trace the calls between my applications or my microservices in order to find bottlenecks, performance issues, and so on. And Dapr does this out of the box. It supports the Zipkin protocol, which means that it works with anything that supports the Zipkin protocol. And then it has an open telemetry collector, which adds more to the tooling that it supports in terms of logging and metrics and so on, right? So it works with App Insights, Datadog, Zipkin, Prometheus, Jaeger, and so on. Secrets, I think that's very straightforward. What we need to ensure in secrets is, and that's very common across most customers that we work with, is you don't really store the secrets in your application code or repository, right? Or you just invoke them in your pipeline and so on. The best practice is always to get your secrets during runtime, and that's what we're trying to achieve with this time, with the secret component, right? Where you get your secret only during runtime, and then that's the component. For instance, if HashiCorp Vault, that's my component, and this where I find it, and how can I authenticate against it, and then in my application during runtime, I'm just going to get the secret, right? And then the secret will just go in my application, and that's it. Once I delete my application, the secret will be deleted as well with it. It's still in the vault, right? But it's deleted from its state. Finally, a few things, the input triggers before we go into demo. Input triggers, so I need my application to react to an event that is happening from the outside, for instance, Twitter, Kafka, Twilio, and so on. So that's the input triggers, right? And then the output triggers, or the output bindings, is exactly that, where I need my application to emit events to an external service, right? the merit there, or the whole idea there, is normally what you needed to do to get Twilio, for instance, to work in your application is you added the Twilio API, or sorry, SDK in your application, and you started adding that logic. If you're going to use Dapr and then you need Twilio, the component is there. You don't have to really add anything that is code specific to Twilio. All you need to do is just call the binding API, and then that's it, right? So there's no SDK involved in the process in your application. Your application will just talk to Dapr, and Dapr will handle the rest. Right? That's a Dapr binding for Twitter, right? It's, again, this is Twitter, and then the binding is Twitter, and then how this is my API keys. Don't get hung up on like where the secrets are and so on. The secrets can be stored in different places and so on, but this is there just for simplicity. Okay. So
we just have a question from two questions. We have a question from Steven regarding the vault. What are the pros and cons between storing secret in a vault compared to built-in Kubernetes secret?
The pros and cons.
Yeah.
There are only cons. There are no pros to storing secrets in Kubernetes. Well, the only pro when you store the secrets in Kubernetes is just easy, right? That's the only benefit that you're going to get out of it, because it's easy. It's part of the Kubernetes API. You're going to get your secret there. But the problem is the secret in Kubernetes is base64 encoded, which means anybody who has access to the secret can get the secret and then just see it, right? And that's something that we try to avoid. Having the secret in a vault means that your secret will get only injected in the application during runtime, right? And then if nobody has access to your application, then nobody can see the secrets. So that's the idea. So normally what we recommend to most customers is externalize your secrets. Don't really, like, even if you say I'm using encryption and text and I'm encrypting its CD using my own secrets, that's not really a good practice. You have secrets in your cluster. Somebody has access, or any of the admins or whatever have access to your cluster, then they're going to get access to the secrets. So normally Vault or Key Vault or AWS KMS is a better approach in general. And it's better also for, like, once you have many secrets, it's better as well, because it's purpose-built for that, right? Okay, thank you. And we will have another question from Daniel, but I think it was at the beginning of your talk. It was regarding edge infrastructure. What is it? It was really edge infrastructure. Yeah. So when we say edge, it's anything from your data center, right? So that's edge for us. We're the cloud, right? So anything that is your data center and beyond. So the literal meaning of edge is IoT devices. So that's a car, that's a small device that runs on a chip, and so on. That's the literal meaning of edge. Anything from your data center down to connected devices, that's edge for us. Yeah. Okay, great, thank you. Is there a question? Okay. So the demo. Distributed calculator, because we can, right? So how we can complicate our calculator, right? So it's a really very simple application. So we have a 5 microservices type application. It has a Go application, our application written in Go to add, application written in C# to subtract, application written in Python to multiply, and then another application called Node for divide, right? Division. I think the whole idea is just to show, like, the different microservices written in different languages, and then how Dapr will just simplify the whole thing. And eventually we have a React front end that will technically show the calculator and then interact with all these microservices. Eventually, all the state for this, we're going to ensure that the state is stored. So the last operand that you applied in your calculator will be persisted. If you refresh your browser and so on, it's going to be there, right? And in our case, we're going to be using this. Cool. Let's bring in VS Code. Where's my mouse? Okay, got it. I hope it's not too small. Is it readable? Okay, very good. Yeah, it's okay. Very good. Okay. So let's start by just working our way through. We're gonna get Dapr from our local machine to Dapr running also in our local machine. So I'm gonna run Dapr normally in my local machine as processes. Then I'm gonna run Dapr, or they run the calculator and a Kubernetes cluster running in my machine. Then I'm just gonna ship the application to the Kubernetes cluster running in Azure, right? So that's how we're gonna walk through the demo, right? Dapr has a CLI called Dapr, right? You can install it. So what I'm going to do there now is uninstall what's already installed, and then Dapr initialize my local machine. And now what should happen is technically Dapr should just initialize its components. So I'm running the Kubernetes cluster also in Docker, so that's why like you see so many things. But nevertheless, what I did there is just to check the containers that were installed. So I did the normal installation, which means that Dapr already knows that it's going to run Docker. If I add the -slim to the initialization, then it's going to install the rest of the things using processes, right? But what it installed is Dapr zipkin and the Redis for me, right? So that's what it installed, and it also created in my home directory a folder called Dapr, right? So if I'm going to go there and so the config. So the config is the configuration for the Dapr itself, right? You can add a lot of things there. The default one, this is by default, right? It just enables the tracing. So the sample rate is 1, so that's 0, 1. 0 is not enabled and 1 is enabled, and then the endpoint. So that's the zipkin for the tracing, right? So that's by default. You can change all of this, of course. And then components, it creates 2 things for me. So it's state store. So it created a default state store for me, which is Redis, and another component for PubSub. That's also Redis, right? So that's the local installation, nothing, just Dapr in it, right? Now, on the application end, let me just run parts. I'm not going to run the whole application because that's going to be too many. So I'm just going to run the node part. I'm just going to then go through the code. So that's the node part. Okay. Just notice that to run my application, Dapr, run application IDs. The application ID, this is exactly the application name. So this is how the service discovery works. Each application should have an application ID, right? Then my application port, right? Then how I'm gonna expose the port on Dapr. So that's 3502. That's my sidecar port. And then the rest is what you know, node app.js, which is run the application, right? Run. Hopefully it works. Okay, good. And then I'm just gonna run also the Python app. So I'm just gonna do the division and multiply, right? This works. Very good. It's exactly the same, right? So Dapr run application ID multiply app port, then Flask run, right? So that's all there is. So if we go through one last thing, so we save on time, we can run the front end application. And then we go through the details, right? Whew. Right. So this is the Go application. There is nothing really in it. That's normal Go app. You don't really have to know how to read like Go code, but that's the you know, we're just creating a function to do the addition, right? So nothing really in there, and then we're just using Mux or Gorilla Mux to just expose the API. So add, right? That's the Go application. The Node application more or less is yeah. So it's an Express app. And then it does division. We expose that division, and then it just does the rest of it is just the logic. Same goes for the Python app and the C# app. There is not really anything that is Dapr specific in the application code, right? In the React app, however, this is where all the magic is happening, right? So again, it's a React app. There is Express, there is React, there's Axios, so all the things that you know in Node.js. But there, we created a Dapr port. So it's the default one, 3500 for our case. And we created the Dapr URL. So again, what we were showing in the slides, localhost, Dapr port, so 3500, and then invoke. That's for the Dapr URL. We created state as well. So that's the state store and Dapr port, and then the API port. So we just created a state URL, right? Now, from an application perspective, post, calculate, add. Post, it's Dapr URL, add, application. So this is my application, the application ID, method, and then add. That's the method, right? Exactly the same for subtract, exactly the same for multiply and division, right? So it's Dapr just, standardized for me, like how can I call my services? And I just call them using exactly the same logic, all of them. I just need to change the method itself, right? The other thing is we added state to the application. So, okay, that's all the same. Yeah, so I'm persisting states as I do any operation. So I'm just persisting the state to the state URL, right? So that's just to ensure that there is a state. Okay. So again, nothing Dapr specific code in there. It's just calling the API for calling the URL for Dapr. That's all there is. Now, if we go to the React application, that doesn't work because this maybe no. Fine. It's working. Well, it should work. Let's try. Okay. Right. So we did the division on multiply. So 9 times 9 equals, right? And then 9 times 9 equals. So the calculator just works, and what I need to show you is tools, developer tools. Okay, so if we refresh them, because we have the state stored in Redis, right? So the state just is persisted already, right? So if we add another operation multiplied by 9, so persist, right? It's just persisting the state, right? So that's all there is. Again, we got service discovery. We got communication between the services, and we got state store just by using a few pieces of code just to run in our application, right? And again, the main application code wasn't intact in that case. Okay, so that's running it in my local machine. To stop the application, that's all there is. Dapr stop and then the application ID. So let's try now to run it in a Kubernetes cluster to see how things will go. To initialize and Kubernetes cluster, let me see in which cluster am I? CPX. And the cloud one. So let me just change this to the local one. So that's my Docker desktop Kubernetes, right? So I'm going to run it in my local cluster. I'm going to initialize Dapr there. Probably it's going to error out because I installed it already, just to save time. Error out, of course. And then normally what it's going to install is the dashboard, the operator, the placement, the sentry. This is the mutual TLS stuff, and then the sidecar injector, right? I already installed this to act as my state store, so it doesn't install Redis in the Kubernetes cluster in that case. So Redis is already installed. I installed it using Helm, so there's nothing really, it's very straightforward. So that's my Redis cluster. These are other two applications I'm running, so it's not necessarily part of this. Then I'm going to apply these and just show you what's running there. Okay. So let's have a look at the deployment manifest. If you don't know Kubernetes, that's fine, right? I'm just going to show you a few things. That's the deployment manifest for Kubernetes. So it's called deployment. This is a subtract API or the application. The important part is this. Dapr enabled this too. which means that I instructed the API injector, the one that we saw, the sidecar injector, that they go and inject an Dapr sidecar, right? My application ID, this is the application ID. This is how I do service discovery, my application port, and then the config. The config is this one. That's also for tracing, right? So how I'm going to do tracing. So that's all there is. The rest of the applications are exactly the same, right? So all of this, and then the last thing is technically where should I get my container image, right? That's the last thing in the application. But all of them are exactly that. And what I've done as well is I created a component of my own for the state store. So that's what is in our case. So it's similar one to the one that you found in the local deployment. The difference here is I'm using a Kubernetes secret. That's again, that's for sake of simplicity, right? If you're gonna see, so now the application should be deployed already, right? You're gonna always see 2 from 2, right? 2 from 2 means that this is one container is my application, the other container is the sidecar for Dapr, right? Now, if I'm gonna get the service, right? Just gonna do port forward and test the application, right? So kubectl port forward. I should run on let's see. No, not 80, right? It's 8,000, right? So right. So yeah, now subtract should work. Exactly. And the same persistence and so on, everything is there, right? So that's the application now is running in my local Kubernetes deployment. So I'm going to stop that, delete all of this. The last part is just move everything to the cloud, right? I already run a Kubernetes cluster in AKS, so I just installed a simple Kubernetes cluster in AKS with a single node, right? So node count is 1, and okay, it's working now. So I just need to change now to my cluster in the cloud, which is AKS Dapr. Again, the initialization was done already, so I'm not going to really do the initialization. So if we can get the pods there, it's there already, right? I installed Dapr, Redis, and I did this already. So if I applied exactly the same manifest there in the cloud, right? So everything Redis is there, and then the okay, the manifest will not apply. So let me apply the manifest. It's gonna take a while. Right. So let's see. While this is working, let me see questions. Okay, cool. I love hacks, right? By the way, speaking about VS Code, there is also an extension for VS Code for Dapr, right? So you can use it in order to interact with APIs and then bootstrap components and scaffold and so on. All of these type of things out there, right? Now, what I needed to show is a small thing, and then we wrap up, right? So everything's running. I'm just gonna do. Let's do the port forward. Okay, so now it should be running in the cloud. And I should go there and hopefully it works. Okay, so that's running in AKS, right? 9 times or 5 multiplied by 9 equals, right? So that's now running in the cloud. But the other thing that I wanted to show is the tracing, right? We're almost running out of time. I'm just going to show you a very small thing. Okay, and boom. Not going to do like the proper tracing. I'm just hopefully there is some data for us. Yeah. So so Zipkin is running. If you know how to run Zipkin, then you can do all the things. This is the dependency tree. How things are working, and then you can technically just delve into the code and see There are like further demos where I deploy like a buggy application and then trace the code and so on, but we don't have time for this. Yeah, that's I think what I wanted to show. Let's delete all of this. Okay, back to the presentation. Okay, hopefully that showed you an idea or gave you an idea of what Dapr is. I'm not sure if nobody asked about this, so I'm not going to cover it. Dapr versus service meshes, but it's not a service mesh. That's it. Assuming you have a question, just tell me if you have that question in mind. Nevertheless, Dapr docs are very important. Everything you need, the latest components that are there, how to contribute, and so on. And a lot of examples are there. GitHub, that's where you find this exact demo for the distributed calculator and other demos as well, and then the quick starts as well, right? And the GitHub, you can contribute, you can post issues, you can ask questions, and so on. And we also have Discord channel there. And with that, I think I'm done. Let me just check the chat.
Okay, thank you very much, Mark. Do you have any question in the audience?
Thanks for the great talk. Thank you. Okay, we have. If we don't have questions, then I'll hand over to you, Jon.
Yeah, we still have time for questions. I think I will make this small for me, give stuff in the next station. So we are okay for questions. I have one for you because from the yeah, let's say from the on the client from the client perspective, anything that's changed at the end, the only notion we have of Dapr from the consumer perspective, from a consumer perspective, let's say it's just the URL with the invoke stuff, and that's it. You just have to. It's the only notion you have from. Yeah, it's your entry point, and this is the only knowledge you have regarding Dapr, and that's it.
Right.
Yeah.
So okay. That's all there is. Assuming that you're interested in, I'll just show you a small thing there. Any link to the calculator source code. So the last thing, the Dapr quick starts. There in the quick starts, you're going to find the distributed calculator source code, all of it, right? I wanted to show you this, not the calculator. Local machine, quick start. Secret management, first allocation. This one. Secret management. Yeah. Right. So this is where you can also work with the API itself. Right. So if you need that SDK without calling the HTTP or gRPC, this is where you can just like play with the API. So again, in the quick starts, you have two examples: the HTTP ones, and then the SDK ones. You can play with either, depending on what you like more. I hope that I answered your question for the Daniel for the source code. If not, then it's this one. I'll paste in the chat if I think it's this one. Just scroll back to the quick starts and then I'll just do the quick starts instead. I'll paste it in the chat. Right. Is there a best practice how to define and share the service API to the app? Maybe you normally share for the API. Yeah, I guess. Does Dapr provide some magic on this? Yes. So if you're using gRPC, then the Dapr will just like produce this for you out of the box. So there is nothing really for you to worry about there. If not, then you can use this. Which API? Specific APIs. I'm not sure if I answered the question, but you can come off mute if I didn't answer the question the right way.
Yeah. Okay. Is it okay for you, Raphael? Does it answer to your question? Yeah. I think so. Let's say yes. Okay. Thank you very much. It was really interesting to see it in practice. There is a lot of content. And yeah, regarding the actor, it's really something that we need to deep dive in, because we had pretty great discussion a few months ago regarding actor models, regarding akka, and maybe I don't know what is the implementation behind Dapr and in C# or Java, but it could be really interesting.
There are 3 implementations now. There is C# one, there is Java one, and there is the Python one.
Okay.
Yeah. So the Onions, the akka, and I don't know what the other.
Oh, it's Orleans for .NET for C#.
Is Dapr client and Dapr control plane version on AKS slightly linked? Not always. No. There are minimum versions that you can use for Dapr, or minimum versions for Kubernetes to run Dapr, but normally in most of the cases it's not tightly coupled. But as you can imagine, we're using CRDs and so on. So if these CRDs got deprecated from the upstream, then we gonna introduce the deprecation as well, and then move on to newer versions. But normally you'll be able to just run fewer versions of Dapr and Kubernetes cluster without really having to keep upgrading and so on.
Okay, great, thank you. I think it's time to close it. Thanks again, Mohammed. It was really interesting. I think we have learned a lot of stuff, me at least, for sure. So thank you, and you're welcome to see us again for
sure. I mean,
another topic when you want.
Yeah, if there are any areas of interest in the Kubernetes and container space and folks here of interest, please let me know. We can, I'm again interested in just connecting with the community in Luxembourg. So please let us know, and then we can do more of this. Yeah.
Thanks again. See you guys. Have a great evening. Yeah. Bye.
Okay,
Thanks again.
bye.
Bye.